Matt Roscoe here at the University of Montana, Math 234, a lecture on our section 8-5, greatest common factor and least common multiple in mathematics for elementary school teachers. Okay, so today we're going to talk a little bit about the greatest common factor and least common multiple. I want to define what both of those are and then talk a little bit about the slide method. And then I'll go and talk a bit about what prime factorization tells us about how we can use prime factorization to find GCFs and LCMs. And we'll conclude with prime products rules for GCF LCM. Okay, sorry. So given a list of 2 or more counting numbers, the greatest common factor or greatest common divisor is the greatest counting number that is a factor of every number in the list. Sorry, that is the greatest counting number that is a factor of every number in the list. So let's go ahead and talk about an example here. So what if we did something like 24 and 42 as an example? So what does that look like? So if we want to find the greatest common factor of 24 and 42. Okay, so here we go. We would write first the factors of 24. So the 24's factors are 24, 12. Let's see. Let's try this again. 1, 2, 3, 4, 6, 8, 12, and 24. And let's see, 42 is going to have as factors 1, 2, 3, 6 and 7, 14, 21, and 42. And so what would be the GCF of these two? Well, the greatest common factor, it looks like common factors are 1, 1, 2 and 2, 3 and 3. See, 4 and 4, no. 6 and 6, yes. 8 is not in both. 7 is not in both. 12, 24 is not in both. So the greatest common factor of 24 and 42 is 6. And you might be asking, well, so what, right? And where this really plays a big role is if we think of fraction representation. If you have 24 over 42, then the greatest common factor is the factor that you take out of the number that simplifies it to lowest terms. So you could write 24 as 6 times 4, and you can write 42 as 6 times 7. And the 6 times 6, of course, is a 1. 4 and a 7 stays, so this is just a 1. You can cancel it as a 1, and you get 4/7. So it's the GCF that plays this big role in simplifying fractions to lowest terms. Well, what about the least common multiple? Given a list of 2 or more counting numbers, the least common multiple of these numbers is the least counting number that's a multiple of every number in the list. Okay, so let's take a look at what we mean by that. So what if we try to find the least common multiple instead of the GCF of 24 and 42? So okay, so that means we've got to find multiples of 24. The first multiple is, of course, 24 itself, and then 48, 72, 96, 120, 144, 168, 192. Of course, I've done this before, but I guess in my notes, but you should be thinking this is times 1, times 2, times 3, times 4, times 5. Let's go ahead and do 42. Its multiples are 42, 84, I don't see it up here, 126, I don't see it up here, 168, and now I do see it up there, so I can stop. So it turns out that 168 is the least multiple that's in both lists. And so we can say that the LCM of 24 and 42 is 168. And you're asking again, well, so what, Roscoe? When will I ever use this? Well, where you would use this is in, again, a fraction setting. If you have 1 over 24 and you're adding to it 1 over 42, what you need is what's called a common denominator. You need to scale up 24 and 42 so that they're in the same number of units so that you can then add the numerators. So the right number to use here is the LCM. It turns out that 24 times 2, 3, 4, 5, 6, 7, 24 times 7, and 42 times, let's see, 1, 2, 3, 4, so this is times 4, is how I get to each one of these. So let's see, so it would be 1/24. If I want 168, I've got to multiply by 7 over 7. And then 42, if I want 168, I got to multiply by a 4 over 4. And so what does that give us? That gives us 7 168ths plus 4 168ths, which equals 11 168ths as our answer here. So this is the place really where LCM comes into play in the middle schools, in the middle grades. Well, it turns out that there's these neat methods for finding LCMs and GCFs, and let me show you how it works. This one method is called the slide method. So we'll use 900 and 360 as our examples. Okay, so the way the slide method works is we start with 900 and 360. And we sort of make a t-table or a double t-table. And what we try to do is, like in the lattice method for finding factors, we just sort of do the lattice method for both at the same time. We ask, what number could I take out of both or divide out of both? And what you really want to do is to take the biggest one you can right off the bat. So I'm going to just start with 10. I can definitely get 10 out of both. I get a 90 and a 36. I see that both are multiples of 3, so I'll take a 3 out next and call it 30 and 12. I see that both have a 3 again, don't they? Oh, so I could have taken a 9 up there, but I'll take the 3 now, 10 and 4. And then lastly, I see that I can take a 2 out. Yes, a 2 will come out, and I'll get a 5 and a 2. And then when I get to this spot, I know I'm done because the last two numbers here share no other common factor other than 1. So I could take a 1 out, and it would be 5 and 2. But I've divided out all the common factors that I can. So ask yourself now, where do you think the greatest common divisor is found in this lattice? And then where do you think the least common multiple is? And we'll talk about that in a second. Okay, so if you said that you think that this is the greatest common divisor, then you are right? Because the greatest common divisor is the number that divides both of them, and it's the largest number that divides both of them. And so all of these divide both of them, so as a product, they should be the GCF. So this guy right here is the GCF. So the greatest common factor is 10 times 3 times 3 times 2. So 10 times 9, that's 90. 90 times 2 is 180. So 180 is the GCF. Okay, so that's the part that they share, right? So now, how would I know the least common multiple? Well, think about it. If this is the part that they share, and 900 has 5 of those, and 360 has 2 of those, right? Then to construct the LCM, all you have to do is think, well, 360 is going to need 2 of those, but 900 is going to need 5 of those, right? So if I take 10 of those, right, 10 of these, then that should be a multiple of both 900 and 360 because it's got 5 and it's got 2 of them and it's got both of them together. So hopefully that makes sense. The GCF, the LCM, is going to be equal to the 180, or times 5 times 2. And so maybe I should make this in green, right? 180 times 10. And so that's going to give you 1800 as the least common multiple. I hope that makes sense. The least common multiple is a little harder to understand, but think about it this way. 90 has all of this in it. 360 has this plus this, right? So this is in both, and this is uniquely in each. So we have to include it in the least common multiple. So I put that in and multiply it by the 180. Okay. Let's try another one. What if we were asked to find the greatest common factor and least common multiple of 1080 and 1200? All right, let's see what happens. So I don't know if you see this. I see that both have a factor of 10, 108, so 120 here. They both have a common factor then of, well, I could say a 2 or a, yeah, let's take a 2 out of there. This would be 54 and 60. Another 2 will come out of there. So that'll be 27 and 30. Both have a 3 in them, so I'll take a 3 out of there, and that'll be 9 and 10. And 9 and 10 share no other factor than 1. So we're ready to write the GCF of 1080 and 1200, sometimes written this way, is going to be 10 times 2 times 2 times 3. So let's see, that's 4 times 3 is 12. 12 times 10 is 120. And the LCM of 1080 and 1200 is going to be the GCF, the 120, right, this part, times the pieces that are unique to both numbers, the 9 and the 10. So times 9 times 10. And that number seems to be a lot bigger than the last case. It's 10,800. So you can see it's a multiple of 10 here, and I think it's 1200 times 9 as well. So it's kind of interesting to see how the other piece, the unique piece in each one, turns out to be the multiple. 1080 times 10, 1200 times 9. That'll give you the 10,800. Okay, so that's one picture of how methodology to find LCMs and GCDs. Let's go ahead and talk about another view. What about prime factorization? So how can prime factorization help us think about these things? So let's go ahead and find the prime factorization of both 900 and 360 and look and see if it somehow informs us. So I think I'll remind you, let's go ahead and pull up my overhead here. So we're going to try to find the GCD and LCM of, what were the numbers, 900 and 360. So let me do this again, 900 and 360. So the GCF and the LCM. Okay, so let's think about this first. If I find the prime factorization of 900, let's do that first. It's 3 and 3, 2 and 50, 5 and 10, 2 and 5. So 900 can be written as 2 2s times 2 3s times 2 5s. So that seems to be the prime factorization of 900. How does 360 look? Let's do that in red. Try to get it on the same page. 360 is 36 and 10, 6 and 6, 2 and 5, 2 and 3, 2 and 3. So that means that 360 can be written as 1, 2, 3 2's times 2 3's times a 5. Okay. Probably the easiest question to ask first is the greatest common factor. So let me write these out. And in particular, what I want to do is I want to make it into a Venn diagram with these two factorizations. So I'll draw a red circle and a blue circle, and I'll ask what goes in the middle if the blue circle's 900 and the red circle's 360. Well, I can see I've got 2 powers of 2 here, and I've got 3 powers of 2 here. So what I'm going to put in the middle, what they share is 2 squared. There are 2 powers of 3 in both numbers, so times 3 squared. And there's 1 power of 5 in both numbers, so times 5. And so that's the part that's in both numbers, 2 squared, 3 squared, and a 5, 2 squared, a 3 squared, and a 5. So the part that's in the red number that's not in the shared part would be a single power of 2. And the part that's in the blue part that's not in the overlap would be a single power of 5. So just make sure this makes sense. 2 2's, 2 3's, 2 5's in the blue, yep. And in the red we got 2 2's plus 1 more, so 3 2's, 2 3's, and a 5. Okay, so there it is. And this number is 360, and this number is 900, right? Oh, it should be in blue though. And I'd ask you to sit and look at this for a second, then ask yourself, well, where can the GCD be found, or the greatest common divisor? And I think it's pretty intuitive to look right in the middle, isn't it? I mean, this is a part of the red number. This is a part of the blue number. So it certainly is a part that's a factor that's shared by both numbers. And by the way, it's the biggest factor because we've kicked out everything that doesn't belong there, right? So this piece right here, maybe I should do it in a different color. Let's try to see if I can get my green fired up here. Yep. So this piece right here in the overlap, when you think of numbers prime factorization as a Venn diagram, that piece is the GCF, which is the same thing as 4 times 9, 36, 36 times 5, that's 180, right? So if I multiply 2 squared times 3 squared times 5, I get 180, right? And then if you think about what has to happen to find the least common multiple, well, this is the number 360, do you agree? And to find it as a multiple of 900, well, this is the number 900, right? And to find it as a multiple of 360 is sort of how do I get a multiple of both numbers? And I think it's fairly straightforward to see that to get a multiple of both numbers, I need the part in the middle, and I need the 2, and I need the 5. So this piece, the whole thing, is what we can think of as the least common multiple. That's going to be the middle part, the 180, times the 2 times the 5, so times 10, which is the same thing as 1800. And I believe if you go back in your notes that you'll find that these are the exact same solutions that we got when we conducted this same investigation using the slide method. So let's do it and see if it works for the other 2 numbers that we were given to investigate. Let's see here. What were the other 2 numbers? 1080 and 1200. 1080 and 1200. So let's first find 1080's prime decomposition. So I'd see 10 and 108, 2 and a 5, 2 and a 54. 54 can be written as a 9 times a 6. That's a 3 and a 3 and a 2 and a 3. So 1080 is equal to how many 2's? 1, 2, 3. How many 3's? 1, 2, 3. And how many 5's? 1 of them. So it's 2 to the third times 3 to the third times 5. And the other one is 1200, which is, I guess, 12 100s. That's 2 and 6. Let's do 2 and 50. That's 5 and 10. That's 5 and a 2. That's a 3 and a 2. So 1200 can be written as 1, 2, 3, 4 2s. So 2 to the 4th, 1 3, and 1 2 5s. So similar bases but different exponents for sure. Just checking to make sure I've got 2 to the third, 3 to the third times 5. Yep, I've got the same numbers here. So once I have that prime factorization, then I can fill out my Venn diagram for the two numbers. I wish I could keep both of them on the screen for you, but I can't. But you'll have to rely on your notes. So this is the number 1200. This is the number 1080. And let's think about what goes in the middle and in the two parts and pieces that aren't shared. So when I look in the middle, I can see that the smallest power of 2 is 2 to the third. So there's a 2 to the third. There's 1 3 that's shared by both and 1 5 that's shared by both. So a 3 and a 5. Okay, to fill out the red number, I need 1 extra 5. I got the 3, and I need 1 extra 2. To fill out the blue number, let's see, I've got 2 to the third, check. 3 to the third, so that means I need 3 squared here. And then 5, check. So this is the way the two numbers compare in terms of their overlap. And just reminding you here that this piece in the middle is the GCD, or the greatest common factor. And it's going to be 15 times 2 to the third is 8, so what's that? 15 times 8, it's 120, and I believe that was the number that we got as the greatest common factor. It certainly divides 1200, and it does divide 1080. In fact, it's 9 times 120 gives you 1080. And then to find the LCM for this number, we would just take the greatest common factor and ask what other pieces do we need to make it a multiple of 1200. Well, to make it a multiple of 1200, we need at least the 2 and the 5, right? And to make it a multiple of 1080, then we need an extra 3 and an extra 2. So I guess thinking this way, all of these factors taken together give us the LCM, which is going to be the middle part, the 120, times 9, times 10, and I believe we've seen that number before, 10,800. And if you'll go back and check, those are the two values that we got for LCMs and GCFs when we did this using the slide method. Well, I think that's about all I wanted to cover for today. I hope that you had a chance. I hope that you learned a little bit, something a little bit new about greatest common factors and least common multiples, and I'll look forward to seeing you with your questions on Monday when I return.